Hey there, everybody. Welcome indeed to SkyTour live stream. It's kind of a good day right now, a good time for us because we're trying a new process where we are streaming to multiple platforms at the same time. More about that in a bit. But first, I just want to let everybody know that we also have Daryl Mason with us. Hello, Daryl. How are you?
Hello, Mark. I'm good. You?
All right, all right. Thank you so much.
Hello,
Um,
everybody.
so we're gonna just look around and check on things here to make sure. Uh, I see. Okay, we have Robin Curtis is here. Cindy Murphy. Hi. Daisy and Zoe Amethyst. Wonderful. Good to see you guys. So very nice. Very nice. Um, so we are supposedly streaming to Facebook to the SkyTour live stream group right now. Are you? If someone can go there and check that out for me and make sure that's actually happening, because this again is new tech for us. We're trying some new things here. In fact, send me a message if you go to the Facebook group. Hi, Lucy Clark. If you go to the Facebook group, could you send me a comment and let me see if I see it? Because it'll show up in my chat here. That's actually a chat that's actually an aggregate. It's actually all the chat information. All right, and I'll know immediately because it'll say so. So, tonight we're going to be doing a few fun things. I see our chat box up there. Okay, if you want to see who's chatting, we actually have a chat box. You can actually see the live chat on the screen, but that's going to become somewhat annoying, I think. So I'm going to turn it off for now. And we'll bring it back if needed. But it's great. Good to see you guys. Thank you for coming out. And let's have some fun tonight. And all of you that are here have been here before so far. And I'm actually liking this. This is great. You know, this is neato. Okay. So, what's happening at your end, Daryl?
Say what?
What's happening at your end?
Uh, I've been sending you messages to our chat.
Okay.
You told me not to say it out loud.
Hell, you just did. All right, well, let me go see what you wrote. You can hear me okay, right?
No,
You can't.
no.
All right. All right, folks. Well, since it's a new platform, can you guys tell me if you hear me clearly or if I'm cutting out on you? I should not be cutting out. If I'm cutting out, then that's not cool, so I have to fix that. Again, the headaches of a new platform. Okay, Michael Hedrick says, sounds great to me. Lucy says, I can hear. Daryl says, I'm muffled and cutting out. Try something, Daryl. I'm going to go in and just see if I can figure out why you're having trouble. Just a minute, guys. By the way, that's the star Sirius. And we're still looking at Sirius. If you notice, the telescope is kind of on an angle, a little over. So, let's go and let me just look up a couple things here. Okay, you're heard very well, Daryl, and so am I out in the audience. But if you're having trouble hearing me here, that might be a Skype issue, which actually is better to try and figure out. So let me go look.
They said I'm not as loud as you.
Okay. Well,
I can raise my level here.
I just did. I just raised you. So
Okay.
you should be now as loud as me. And let me go and look at my settings. This is all new stuff for us, guys. Not the stream, but what we're doing is new. Okay, well, my microphone is set right. Yeah, people are saying they hear you just fine. That's good. Cindy says you both sound better now. Well, that's pretty cool considering I didn't do anything. All right. Now, if I... all right, let me see here. Actually, Skype has all the settings that I should have.
You don't sound bad at the moment. You still don't sound like you used to, but I can understand you for the time being.
All right.
Bill says to check Skype.
I already did. and Skype has my microphone here, the one that I always use, this one right here. You can't see it. It's in there blocking me. Okay. And it has if it's on Skype, I have it on the USB mic, which is here. And other than that, you sound good to me. You're not dropping out, but am I still dropping out on you?
Well, you weren't. Now you are again a little bit. I don't know if you're moving away from your microphone or what.
Well, I can't always face toward the microphone, but if I have to move it a little bit, I guess I could. But then it blocks my view.
I'm not sure if that's what the problem is.
All right.
I mean, I hear you, but you do drop out.
Okay. All right. Bill says you were fine. So I'm wondering what that's all about. Hey, Bill, can you go to Facebook and see if we're on Facebook? Oh, wait. Cosmic Ray says video out on Facebook is okay. Oh, good. Very good. All right, hey, Cyclone, how are you? Yes, I'm on Skype, Cyclone, and so is Daryl.
Lucy Clark says you're not as loud sometimes.
Okay. I mean, I am, if I talk loud, that's one way for my voice to go downhill fast. But you're right. But thanks, guys. Well, let's try to do some astronomy tonight. I think that'd be kind of fun. Hello, Bonnie. Anahata77 is here with us. Uberku, nice to see you. Cosmic Ray, nice to see you as well. I mentioned Robin. Good to see you, Robin. And Michael Hedrick's with us. Sam S. is with us. And I said hi to you, Lucy. Daisy and Zoe, I said hi to you. That's wonderful. You guys are here. All right, so we're at least going from here to, Facebook. We're also streaming, on Facebook, we're streaming to the SkyTour live stream group. And on Trovo, we're streaming there and streaming to Twitch as well. So, in a few days, we'll be doing a stream to Rumble as well. So that's good. All right. So let me see what we got going on here. All right. So, this is Sirius, as I mentioned, and okay, that's what it looks like right now. This is our gain. You know, one of the things that's really important, of course, that we talk about is the gain, and that's, of course, something that we must care about. Obviously, the gain shows us a lot of. The gain increases the sensitivity on the sensor, and the exposure will just add light for that many seconds to that increasing gain on the sensor. So that's pretty good. All right. That said, let me just work on this little something here. I think there we go. All right. Okay, so that's all good. I'm going to try one thing really fast, so give me a moment here. All right, there we go. And let's bring this back. Okay. All right. Oh, there you go. new. That's the wrong one. Try that. There we go. Okay, so there we go. And now, let's see here. I gotta take this and get this back. Okay, just a minute. I gotta organize this again. I needed to restart the remote system, which I did, so we're all good. And this guy's good, that guy's good, okay. I'm getting over a coughing cold that I had, so pardon me for that. Just a minute, guys. I'm just working out an extra little wrinkle here, and then we'll get going. I could have done it. There we go. All right, that looks like that'll work. All right, so status.
Lucy Clark was timed out by Streamlabs.
What? Why?
I have no idea. Deleted her message also.
Oh, did she? Okay. All right, hold on. That's one of those settings that we have to work out. Okay. 1 second. Lucy, you should not have been timed out.
Streamlabs shows as a moderator, and
it is.
Said, Lucy Clark, please refrain from posting links.
Yeah, no, she's able to do that. Okay. All right, it won't happen anymore. I just fixed it. Sorry, Lucy. My mistake. New technology. All right.
I assume Streamlabs is what you're using instead of OBS now?
Well, it's actually called Streamlabs OBS, and it allows us to do a ton more stuff. Lots and lots of additional work that we could just never do. Now we can. So let's bring up our planetarium, and one thing I'm going to do here is I'm going to just get this. All right, that's good. That's really close. So I'm going to move a little bit to the west. Okay, and then a little south. I'm going to center Sirius. Okay. One more little kick. And then what we're going to do is take us to a few items out here that are really cool to see. Near Sirius, as a matter of fact. Now, we have a waxing gibbous moon tonight. And if people want to see the moon, I guess I could show you the moon. Why not, right? So let's go to Sirius, and now we just align everything. There we go. Okay. And that is good. So, we'll come out of this, get out of that. Okay. Well, Daisy and Zoe said they lost their connection.
Nice.
Yeah, I don't think that was from us. But you could actually go. You could actually see it if it's on Facebook too. Okay, let's now do, like I said, let's do some astronomy. All right, so first things first, let's go back here now that this is all set up. Let's check out something right nearby, which is kind of fun. All right, and I think you know where I'm going.
M41?
Yeah. Why not? There it is. A little beehive, it's called. It's actually a very pretty cluster. And we'll center up on it. And then we're going to tell the telescope to go there. So you watch, the telescope won't move very far. It's going to come down a little bit. Excuse me. Oh, and there it is. Okay, there is the little beehive cluster. Let's give ourselves a, now that we can, because we're further along, it's darker out there, we can do a 1 second exposure. There we go. And let's do that. So now we'll there you see all those stars. This is a young cluster, relatively speaking, and it's just down below Sirius, the star we were just at. And if we look at it in our planetarium, and I scroll out just a little bit, you can see where Sirius is. And then almost directly south of Sirius on the same line is the little beehive cluster. Really, really pretty. All right, and that's, of course, in the constellation of Canis Major. You know, so I think that's pretty cool. And Cosmic Ray mentions Venus. Yeah, I actually looked at Venus the other night. Now, again, we're a wide field scope, so Venus is tiny in our scope because it's actually not as close to us as it could be. In fact, I think it's almost partway on the other side. It's a little bit further than its midpoint from. I guess I should say where it is in its orbit. I can't give you the exact, but it looks like a waxing gibbous or waning gibbous Venus to me. And when I looked at it, I wasn't sure if that's exactly what it was.
Yeah, it's kind of a lozenge shape right now.
Yeah.
It is still, strictly speaking, on the far side of the sun.
Yeah.
It's coming around. When it's half lit here, it will be at 90 degrees.
Yeah.
To us and the sun, and that's when it crosses that line. That's when it'll, strictly speaking, be on the same side of the sun as us.
Gotcha.
Then it'll start turning into a crescent.
Yeah.
And greatest eastern elongation for Venus is either May or June. I forget. I think I've seen statements for both.
Okay. Well, here's what we're going to do right now. Since we're looking at this, we'll take a 15-second exposure of this cluster. No, I'm going to go 12 seconds. You might say, why? Well, because I just want to capture a fair amount of it, but there's a bright moon now, so let's just see what that brings us. So we'll take off that and go into our live stack. All right, and our live stack is oops, I got to clear it because that's Sirius from last time. Okay. All right. So this is our stack here. I know it looks bright, but then I'm going to process and give us a color shift. And that should do it, yeah. So what we're doing now is we've done some preliminary processing on the cluster, and it shows the colors of the stars very nicely. Now the moon is not that far away, but we can actually kick out much of that light. You'll notice a little red ring. That red ring is the remains of the sunset light in the sky, because it is only 7:55 out there. So we're getting a little bit of that sunset light left over. It's very sensitive.
I believe your astronomical twilight in Arizona tonight there is 8:15 p.m. local time.
Yeah, so we're a few minutes away.
You might note some of the stars in the cluster are reddish. We've commented on this before, no doubt.
Let me zoom in on it too.
Just like looking at one of the clusters in the double cluster in Perseus, that all the cluster stars are the same age, so they should all appear similar. Yet some are turning red already, and that's a sign that some of the stars are at the cusp of changing color and temperature and magnitude and classification.
Yep. And at some point, Daryl, I think we're going to have to do a good in-depth stellar evolution talk, maybe on SkyTour Radio, probably not here. And for those that may not know, I'm an astronomer. That's what I went to school for. And I've taken my astronomy into the public outreach to create this beautiful system you see in front of you. It's one of 3 that we have. This observatory is out in the Arizona desert. And behind me is a telescope that is, I can show it to you actually right now. Like back there, you can see a telescope, kind of barely. But that telescope back there is the East Coast telescope system. And we have this West Coast telescope system. And we're having a third that we're going to be purchasing and installing in a different location out in Arizona. So far, that's the plan. So I think that'll be very good for us. So there won't be any excuse to not be streaming one at night. It's really perfectly clear here in Connecticut right now. And our skies are a little bit more light polluted than the Arizona desert, but it's still not that bad. It's not as good as Arizona by far, but it's still not bad. So as you see, as it gets darker, okay, you can see now that that red is retreating to the sides. And so when we pull out of the center of the image, okay, you'll see that we actually have it's queuing up right now. There we go. All right, so there is the remains of the sunset light. Okay, why is it dark in the center? Because we're doing a special process on these images as they're being taken. We have what's called a flat field, a flat frame. Okay, so the sensor tends to be bright in the center because much of the light is directed to the center. All right, and as far as the outer areas, less light is directed there. So if we don't negate it, then we're going to end up getting a bright center on everything we take a picture of. So what this does is it does the opposite. It has a bright center, all right, and darker outside, and then we subtract that from the image that was taken to give this image the inverse of that. So it'll allow us to have a darker center, and it'll be even. Once it's fully dark out there, this will all be even. You won't be able to see a difference here. So we're waiting, you know. Hey, Donald Kunzer, how are you? Donald says, I just teleported in from another live podcast. Cool. Yeah. Lucy, I'm glad you're back, and I'm sorry about that. I fixed it, so it's not going to have a problem anymore. You know? Okay. So let's see if we can do an adjustment here. There we go. So it's getting there. Getting a little better. All right. So we'll call this, here I put the description up here, M41. This is in Canis Major. Okay, it's called the Little Beehive. All right, and I'll just put that in too, just to be clear.
Izabela's here.
Hi, Izabela. There we are. Okay, and we'll save it.
TK18, I dare say we know what size all these cluster stars are. Not offhand, we'd have to look them up, but
You don't know
I'm sure
by memory?
no.
I don't either.
Give me just a second, I could find out, or Google is your friend.
Yeah, Google is your friend for sure.
Hang on.
Are you saying the size of the cluster or the size of the stars?
I think it said the size of the stars.
Well, if we know their spectral type and their masses, then we can tell you exactly, pretty much, because they're pretty much all the same.
Right.
Yep. So let's try and do this. Maximize this. And
The red giants are a spectral type K3. Some white dwarfs.
in the cluster?
Yes, I'm still reading.
Okay. Well, what that tells us is that this is an evolved cluster. So that's why I said it was somewhat young. But you know what? Most of the cluster stars, they tend to disperse over time. For whatever reason, this one has not. Okay? And that's okay. That's okay. You know? And as they evolve, they use up their hydrogen, and the core of the star begins to contract because gravity's winning out, because the outward pressure of the radiation from the former hydrogen fusion that was going on in the core is starting to wane, and so gravity begins to win, and the core begins to contract. That contraction causes an immense stellar wind outward, which puffs the star out to a red giant, which is what we're seeing in some of these stars here. Okay, so when we look at these stars, we can see, for instance, we have a red giant right here. We have a red giant right here. There's one here. Okay, there's one out here. Okay, and there's quite a population of red giants in this cluster. Okay, so, and it goes on and on. So you can see there's many, and they're kind of scattered throughout. So it's pretty neat, you know, pretty neat. That's great.
Still looking.
DK says larger than the sun. I suspect so, DK, but it depends on their actual spectral class. Remember, we have hot and blue O-type stars, somewhat hot and blue B-type stars, and then the A-type stars are kind of white. Then we have the F stars, and then the G stars, like our sun. Okay, and then after G, we have the K-type stars, which are kind of orangey, and the M stars, which are very bright, very red. So M stars, like these guys over here, these small ones over here, and that you see them all throughout the field. Sorry, Daryl, I'll just say this. Those are probably the small red dwarfs. Okay, but the large luminous red stars, they're either very close red dwarfs, or they're at the distance of the cluster, which is pretty far away, and are red giants. Go ahead, Daryl, sorry.
They're about 190 to 240 million years old, and they are siblings. They're all about the same age, and I dare say if some of them have evolved to a red giant stage already, they're probably pretty massive stars to begin with. I still haven't found a type for the majority of the stars.
Okay. Typically, you just need to find the type of one star, and you can kind of project the rest. The stars typically form in a cloud that's nearly the same, and so they might tend to form similar stars, unless it's in a really disrupted region of the galaxy. Okay, let me redock this now. And let's bring back our telescope. Okay. There we go. Okay.
A lot of the stars are notably blue-white.
Mm-hmm.
So that would put them more to maybe
B.
B or an A.
Yeah. Now this star, you could say this star might actually be white, and so it's possible when we look at stars like this one here, it looks like it's white.
The hottest star in M41 is spectral class A0.
Okay, so these are all white stars.
Yeah. The bright red star near the center is
That's this
a
one.
K2 or a K3 type.
Which luminosity class, though? Is that like a 3? Roman numeral 3?
Doesn't say yet that I've seen.
Okay.
They seem to be. I've scanned several articles real quickly, and they seem to make more of the red stars than they do of the more populous stars. I've seen it variously described as K2 or K3.
Okay. Okay.
Anyway, Google is your friend if you want to know more.
That's true. Without a doubt. So, once again, let's go cluster diving. So here we're cluster diving, Measure 41. And just to get as close as the system allows, okay, you can see that we can go quite a distance. We're now at over 350% of our sensor. Notice the stars are perfectly round almost, which means that our guiding is really, really good right now. But look at the colors, huh? Look at the colors. That's really pretty. Yeah, and what we can do is remove some of the noise even more just by doing this. And we have, here we go, bring it down. So you can see those stars. Now, every one of those is a star that may at some point host planets, which I think is interesting. Now, I don't think that these stars can host planets that can support habitable zones like ours, because they're A-type stars. They tend to be hotter right off the bat, and because they're close to each other, it's possible that their interactions are preventing planets from being formed if the gravitational motions are dominating the cluster dynamics. David Schmidt, hi. And hi, DK. David Schmidt says, can't stay. Taking my crazy husky pup to a local dog park for some running. Hey, thanks for coming by to say hi, though. It was really nice to see you. Okay, so this is the cluster Measure 41. Really cool. All right. All right, just a second here.
read something interesting at one of the articles.
Mm-hmm.
I've already forgotten the guy's name. He's a well-known, long-time amateur. He talked about the difference between visual and photographic. That visually, when you look at the cluster in a telescope, you see a lot of strongly curved lines of stars.
Yeah.
And the effect disappears when you take images.
Wow.
So there.
Awesome.
Curtis Horn is here.
Hello, Curtis. How are you? There we go. That's Measure 41, the little beehive. Okay. And there we go. Okay, Donald Kunzer asks a really good question. He says, so what's going on between the stars? Do stars absorb radiation from other stars? As a matter of fact, they do. They can heat each other up. If one's hotter than another, then that radiation can be summed and make the corona of those stars even hotter. But remember, these stars are pumping out radiation of their own. So that radiation being pumped out would tend to overwhelm any other fainter, less intense radiation coming at it. So it'll tend to push the other radiation or keep it at bay, so to speak. But the outer corona of the star could interact with the radiation incoming from someplace else. And that's something that that we would be concerned about. We'd want to know what that's from. Okay? And that's because the radiation from the stars in the cluster could be heating up the whole local area and the interstellar matter in the local area. If there's dust in here, then yes, those stars are going to heat up that dust. And if one star is doing it, then 2 stars can heat it up even more, and 10 stars even more, and so forth. Depending on what the dust is composed of, it could be broken down into other constituent particles, or literally broken down to just atoms, and away from dust molecules, for instance. It depends on the temperature. But that was a really good question, Donald. Thank you. Uh-oh. Curtis says he's doing better. He had food poisoning. What happened, man? Jeez.
Extensive reverse peristalsis is what happened. As he put it.
Yeah, I see. Wow. Well, yeah. Well, I'm glad you're with us, man. Claudio Ramos, how are you? Good to see you again.
Andy Morrow's here. Hello, Andy.
Morrow. Hey there. How you doing, Andy? Good to see you. Yeah, so we're actually, I'm enjoying the fact that we're getting people here. We've got 42 of you watching right now. I'm happy. That's now 44. So keep it going, man. And remember, subscribe and like us, will you? I've changed the style of our views to make it a little bit better and less obtrusive. You're not going to see things come out anymore that say subscribe and you know, like, you know. I'll just tell you, you know. But I'm glad that you guys are here, and I want to thank you for coming out for tonight. Now, we've done enough of these, so we're going to pause this, and we're going to save it. Okay, we already saved it once. We're going to save it again, so there'll be 2 of these now. So exactly as seen. So there we go. Now, what does that mean? For those that may not remember, when I save this, what will happen is it goes up to our server. Right now, it's leaving the observatory, going up to our server. And where is our server? Our server is at this location right here, SkyTourLive.org. If you go to SkyTourLive.org, you can, in fact, see every bit of all these images we're taking. Because what will happen is, if you scroll down to the first gray box right below on the main screen, it'll say, take me to some cool pictures. And it'll take you to our server, where you can download this very image, just like you see it here. And it's probably up there already. So as soon as we take these pictures and save them, they get knocked out of the observatory, go up to the cloud where they're brought down on our server. All right, and that server is free to go to. So please enjoy. All right. So, and Izabela was kind enough to provide the link. Thank you very much for doing that, Izabela. RJPX, how are you? Good to see you. Terry, I think I said hi to you. Maybe I didn't, but hello. Terry Haig is with us. Elisha Vieras, how are you? How are you and Darlene doing? Okay. While we're waiting for those answers, I'm going to clear this. We've saved it. All right. And we're going to get out of that and go to what I like to use, which is our night vision mode. Okay. And that's this mode right here. So that's our night vision mode. And I'm going to also bring us down to fit our sensor on the whole screen so we can see what's going on. This is our whole sensor. This distance across is 4 full moons across and 3 full moons tall. All right. If we took an image of the moon, it'd be about this big right now. Right about there. Okay, just a little bigger than the center concentration of the cluster here. Okay. So not bad. All right.
And M41 coincidentally is about the size of the moon.
There you go. There you go. Okay. All right, so let's go now to our planetarium view and pick the next place to go. As you can see, we got a lot of places we can go. All right. Let's see. I don't think we've ever looked at this. Versa 213. It says it's a cluster associated with nebulosity. Well, let's see if we can see that nebulosity with the waxing gibbous moon, which is almost a full moon. Just a few more days. So here we go. We're going now. Check it out. There we go.
On the 8th, on the 5th. I saw that earlier. I have to look it up again.
All right. Okay. I'm going to guess that we're talking about this cluster right here. And oh, look at that little line of stars right there. That's pretty cool.
Oh, my mistake. The 5th.
Okay, yeah, so it's just a couple days. Awesome. Okay, well, let's see if we can see the nebulosity with the fact that we have a bright moon out tonight. All right, this will be a 35-second exposure. And we're going to come out of our night vision mode and go into a stack mode. And you'll see, let me see if I can make it obvious. I'll make it obvious. There it comes. Okay, over there on the right, there you can see a progress bar. And I want to do this. There we go. All right. Let me set the brightness. Set our color. Oh yeah, look at that. That's a beautiful little emission nebula called a diffuse nebula. And sometimes, as you just noticed, we won't see it until we properly match up our colors. So if we look at this a little closer, okay, these are our data curves right here. You see the red, green, and blue. Okay, the white one is the average of all the curves. This line is how much dark space we have. If I move it to the right and climb those curves, it gets darker and darker and darker. you can see how it makes it look a little better, right? This one, on the other hand, this one basically looks for the details in the dark. So what it'll do is this one, if I pull this one closer, you'll see it getting brighter and brighter. But any subtle details like this strange little rift over here become obvious. Like this strange little rift over here become obvious. And then we can pull our darkness back. And now look at it. Now we have a contrast to show this very, very obvious nebula. All right. So that is something that is that we often will do to try and figure out what's really going on in the image. So there we are. Hey, Dean Bostador, how are you? Papa Tom, what's happening? Good to see you as well. Okay, Rocket City Astro, how you doing? Have your telescope out at all? Looking at anything? I think Rocket City, isn't that Michael? Michael Klages?
I forget.
Michael Klages?
Oh, Michael K, yes, I think so. Michael
Okay.
H and a Michael K.
Okay.
And Ronald is here.
Ronald, where you been, man? I haven't seen you for a long time. All right. All right, so we've got 5 frames here that we've taken. And we're only just past astronomical twilight, so we should have a pretty good view. And so this beautiful little nebula is showing up rather nicely. I like it. We can actually do an enhancement. Let's see if we can sharpen things up. Yeah, see, it sharpens up the details. We'll leave that for a bit. And let's move this down a little. Alright. Okay, so this is cool. And this was first and what was the number?
I didn't catch it.
I will. I'll get it. It's first at
213. 213.
213, yeah. First at 213. I just want to have captured it one time so we know what it looks like. Well, Ronald, I'm glad you could make it. Good to see you. Oh, and you know what? As I say that, one thing to make a note of is that Ronald is one of our Patreon guys. Oh, that wasn't rude. I didn't want that one. Let's set this down here. Let me take my... Oh, actually, let me lock this up. There we go. I must have knocked that out. I locked it. How about that? So this is our list of supporters: John P, Izabela M, Ali B, Chief Big Cyber, Vera C, Ronald T. That's Ronald ERRT Radio in the chat tonight, folks. He's one of our supporters. Thank you, Ronald. Martin W, Raymond B, Cindy M. Cindy's in the chat too tonight. And Terry H, one of our supporters, and she's in the chat tonight too. Izabela is in the chat too. She's at the top, as you can see. And I didn't see Vera. Is Vera here tonight? I didn't see it. Oh well.
I haven't seen Vera in a while.
She was here the other night. Okay, we'll
Was
take
she?
that down. Yeah. So we'll just want to make sure people understand that our supporters, they're our Patreon supporters. You can go to our Patreon by going here, skytourlive.org, and on the upper right, when you go to the upper right, it'll take you to our Patreon page, and you could pick a level if you want to support. We got 5, 10, 100, and 200 believe it or not, we have some people at all four, across all the levels, which is neat. We may add some more levels as well. For each level, you get something. At $5, you get a shout out, of course, which I just did. For $10, you get the shout out, plus you get 4 of our highly processed finished images. And I just rotated the next batch in the other day, so you can have the next month's worth of 4 images. And then for $100, you get the access to all 35 highly processed images at any one time. There's more than that, but you get access to the 35. And then for $200, you get everything else, all that, plus you get a personalized tour. And you can join us on the air, and then you can say, I want to see a galaxy. Show me the coolest galaxy. And if you don't know the one you want, then it's up to us to find you the coolest galaxy. And then what you get is a highly processed image of that one. And it's not just one object. If we can fit in your hour that you get with us, if you can say look at 4 different objects and get some really cool finished processed images, then you get 4 beautiful objects of your own. So that's pretty cool, and that's only to the folks that do the $200 level. No, I don't expect everybody to do that at all, but what I'm getting at there is, for people that are serious, we make it, we handle it seriously for you. All right, so that said, we're at 13 here. We're going to go to 14. Right there, you can see the number. Okay, that's right there, 13. There it is, 14. So we've captured 14. Now we'll stop this here, and I put FIRSA to 13, and we'll save it. And you'll notice it says it's saved FIRSA to 14 as a FITS file. That's an astronomical file format, but we're also saving it exactly as seen, and that puts it at a ping file. So if I click on that, this shows you the image exactly as you'll get it if you were to go up to the server and grab it. This is what you'll get. Okay, so that is what we do. Okay, so we'll clear this and move on out and move on up. So that's pretty good. We got a beautiful nebula, even even though we had a 3/4 moon, basically a waxing gibbous moon. Okay, let me okay, here we are, and now we'll get our night vision mode. Ronald, please put up your Mixler link. Oh, you did it already. Good, thank you. I didn't want you to come here and not be able to do that, because you're awesome. Okay, so we are in crazy land here, and we're going to go to another one that's right nearby. All right, there goes a Starlink, and then we're going to go to this one, M46. This one's a pretty one. I'll tell you why when we get there. Okay, so we're just going to skip and jump over to that one. We're actually using Starlink out there. I'm going to tell you something about Starlink. It's a really good system. But I will say this about it. They have a weird business model, because we're in what's called a low capacity area right now, middle of the desert. Okay, it's low capacity, and it means that to have a high capacity, we have to have more coverage with more satellites. Once we have the high capacity coverage, believe it or not, our price goes down. But the price goes up if you don't have high capacity. In other words, for less service, you pay more. Isn't that weird? It should be for less service, you pay less. It seems like an obvious no-brainer. But depending on the way they work things, I don't understand it, but that's what happens. Ooh, the Starlink goes right through. Okay.
Marianne. Marianne is here.
Marianne, Rob. Hey, Marianne. Marianne is instrumental in doing this. If you saw her tweet earlier, actually, you can see her new thing that she's doing. Marianne is starting UAP-PD, Unknown Anomalous Phenomena, and it basically is it's real experiences where the mysterious and the unknown meets police officers from around the world. So UAP-PD is a wonderful new movement, possible show, and potential channel on YouTube. And she is going to be leading that charge with David Rich, another police officer. Both of them, of course, I know very well. Michael Hedrick asked about the comet again tonight.
Yes, I saw that.
Okay, I would like to give that a try in Virgo once Virgo is high enough.
Yeah.
If we can do it. Okay, let's take a look.
Excuse me a moment, please.
Yeah.
Sorry, be right back.
That's all right. Okay, let's take a look at this. You'll notice this is a cluster of stars. This is called Messier 46. And then we got this little thing in there. Now, you might say, well, is it possible that this one star in this young cluster has died? Because that's a planetary nebula. And that little dot in the middle, that's a white dwarf. And so you might say, hey, what's happening there? Well, let's take a picture of it first. And we'll take you to, say, a 30-second exposure with this. Let's do that. I'm just waiting to get it to work. Okay. I'm just trying to change the exposure time here, and it's not letting me right now for some reason. I don't know why it's doing this, but we will get it to happen. I think it has to do with the way Starlink reacts sometimes. Sometimes we have to get more coverage of satellites, and there's a delay. I'm waiting. Why is this doing this? Okay. Patience, folks, patience. Boy, I can't wait for the high capacity satellites. I just can't. I can deal with this with the trails. All right, I'm going to try starting this again. Let's see if that. Look at, see, it was already done. I knew it. Okay. So we're gonna get out of the like that and go in to the live stack. All right. Welcome back.
Thank you. Something happened?
I had a 1 minute lack of responsiveness because of the Starlink satellites. Just didn't overlap enough or something. That happens. As I mentioned, that we have a low capacity location. This is measure 46, so I'm gonna make a note of this. First of all, let me clean it up and give us a little processing. You'll see night and day. Ah, yes. Yeah, we'll get the color correction going. All right. All right, so this is measure 46, M46. Open cluster, planetary nebula. That's why the OC and the PN. Okay. There we go. Let's see if I can make those a little more obvious. Yeah, that'll work. I don't want to be too disruptive. Okay, so now what we can do is darken this up. Okay, and we'll move that over. Put it down here. There we go. So now, you'll notice when we look in here, and I'm going to try and drop the brightness a little bit. Okay, and we'll zoom in. Measure 46 is peculiar because the star cluster is a star cluster that is apparently got a star in it that has died, and the only one. Now it's possible that we could have a star cluster that's aged enough, but the stars are pretty compact, meaning that gravity and mutual orbits haven't acted on them over a long period of time. So we wouldn't expect to see a dying star in that cluster. And as it turns out, we're not. This planetary nebula is way up here in the foreground, and the cluster is way out here in the background. In fact, this planetary nebula is about 2,000 light years away. The cluster, about 4,000 light years away. So literally, you'd pass that cluster and travel for years and years and years before you'd ever get. You'd pass the planetary nebula and travel years and years before you ever get to the cluster. Isn't that cool? Okay. That is pretty cool. Neat.
A lot of very red stars in the cluster.
I know. But look it up. You'll find that that planetary is much closer by 2,000 light years.
Yep.
Now, if you notice that this cluster is approximately the same angular size as the previous one, and the red giants that were in that other cluster were actually quite large and bright. And we don't see that same thing here, you know. So that means something too.
This is much farther away than Messier 41 is, right?
Yeah, this is 4,000 light years away. I don't know how far 41 is. That's, the planetary is only 2,000 light years away.
Yeah. Guess I should have noted that earlier. Let me find out.
That's correct, Izabela says, aha. This is what Mark says, that the Calabash Nebula, which is what this is actually named, this planetary here, is actually a optical illusion. So this guy right here is only 2,000 light years away. And that is the illusion. We see lots of illusions in space.
Messier 41 is a lot closer to the same distance as the planetary nebula than it is the M46 cluster itself.
Yeah.
Messier 41 is 2,300 light years away. I thought it was closer than that.
Mm-hmm. Suffice it to say, the cluster is about twice as far as the nebula.
And for the cluster to be approximately the same apparent size as M41, it's got to be a much larger cluster and
more elements.
Yeah.
Thanks, Rocket City and Cosmic Ray, for contributing that information. RJPX is saying that parallax measurements put the central star, which is a white dwarf, at a distance of 1,370 light years.
I see that. So either it's a foreground object or we've got a conflict here.
No, the central star in the nebula. He's saying it's not the central star of the cluster, the central star of the nebula. So it's on our side. That's one thing that I can tell you right now. We don't ever make the claim that we know exactly how far the stars are. We only know roughly because it takes some serious amount of analysis to figure it out. And getting time on a big telescope to do measurements like this, it takes years just to get that time. You know? You'll notice that it's ringed with some red. Let me, let's get out of that. Let me zoom in for you. There you go. So now you see that this has got a red ring. That's hydrogen gas. Okay? And you can see that there's green. And you see a dark area inside. Now, that dark area inside, that's actually a void in the middle. And the reason that occurred is because at a certain point in the star's evolution, the outer envelope separated from the core and continued to go outward. And that separation causes a dark ring to appear around the star inside. All right, which is really interesting. And again, this goes to the stellar evolution thing I was talking about before. And sometimes the ring is centered perfectly around the star, and sometimes it's offset a little. Why would it be offset? It'd be offset because there's other forces in play when this material is moving away from the star. That white dwarf is very, very hot, 30,000 Kelvin plus, and so it's not doing any fusion. It's just very, very hot remaining stellar core remnant. This is the envelope of the star. All this stuff we see here, all right? And so as the star core contracts into a white dwarf, it causes this massive stellar wind which pushes out, and what it ends up doing is it ends up pushing away the outer atmosphere of that star. And that's why we have a dark ring around most planetary nebula cores. There's a ring like that in some of them, and that's what it's from. Okay.
Mark, Michael Hedrick has a question of you.
Okay. Michael Hedrick, what would improve our estimates of star distance? Anything better than Cepheid variables? Well, okay, Cepheid variables are good for measuring distances to galaxies, because in the cosmological distance ladder, Cepheids were discovered in galaxies. And what was interesting is their brightness and their when I say variable, their brightness increases and decreases over time. The rate at which that does that is related to their brightness, their intrinsic brightness. Okay, and that intrinsic brightness is why we use these particular stars as what we call distance candles. And so Cepheids are pretty good. Now, there is an entire set of processes that we could use. In fact, this cluster could highlight right here a manner by which we can figure out the distance. There is a methodology called the moving cluster method. If we look at the distances these stars are moving on a yearly, 10-year, 20-year basis, that can help us figure out where they sit in terms of distance. And the angular size could be important too, depending on how much mass is in the cluster. So there's a lot of ways to figure out distances to stars, but what we have to do with all the many stars, with all the many astronomical thrusts out there, we have to be able to take the time to do it. Because undoubtedly, if you say, I want to know what this star is right there, what is that star right there? Well, guess what? It might have a name, but we might not know that much about it, because every star in the universe has not been investigated. Every cluster, more or less, has been investigated, but only to a certain depth. Beyond that, it hasn't. So I think that there's a lot left to discover out there. All right, and distances to stars are one of them. We have all kinds of spectroscopic ways to figure out some distances. We know that stars in a certain direction will be reddened. Their light will be reddened because of the amount of dust between us and them, and that gives us some clues. So there's I have a book called The Cosmological Distance Ladder, okay, and that pretty much gives us all of the distance candles. And at some point, I think we'll do that, Daryl. We're gonna go. We did it once on SkyTour Radio, but we'll do it again.
Okay.
Yeah, not now, but we'll do
As
that.
I mentioned in chat to Michael, as you said, Cepheids are more up on the cosmological scale of the distance ladder. That's how Edwin Hubble became famous. He found Cepheid variables in Andromeda Galaxy, and that helped him figure out that Andromeda Galaxy was a totally separate, they used to call them spiral nebulas.
That's right.
Galaxies, as we call them now, that it was a totally separate galaxy from outside the Milky Way. 1924 he did that.
That's right.
And closer rungs on the distance ladder, parallax is usually the first step of the ladder. That's where parsecs come in, all that stuff. I know the satellites that are determining stellar distances now, Gaia.
Yep.
And I forget the other one. Are they still using parallax?
Well, they have the entire. They have the entire Earth orbit diameter, right? That's how they do it. That's how I did it. When I was doing it with our telescope systems at the large observatory I worked at, and we would do it on one side of the Earth's orbit, and then 6 months later on the other side. Now that's like over 180 million miles of distance, and so that gives us, we could go out to minimally 300 light years, and even more with the refinements we've done to date with the orbiting telescopes.
Yeah. Mark Bell is in chat. He asked to add into the call.
Okay. Do we want to add him to the call?
Well, sure.
Of course we do. All right, let me see if I can figure out how to do that here, Bill.
I don't think we ever had Bill on here on the live stream.
I think we have.
Or have we?
Yeah. All right, just a minute here. Okay, just a second, Bill. You ready? All right. He created a shiny new chat. So I think Bill is going to be in here now. All right. All right, Bill, you're in the call, so you can...
Are you sure? I don't see him on our screen.
I have a chat right here. Incoming call. See? Okay.
Gentlemen.
Who are you calling a gentleman?
Oh, we're watching your stream. I'm sharing it on my stream.
Oh, very cool.
And I can hear what you guys are talking about this.
Yeah, I think Daryl ended up getting dropped. Let me just pull him in.
Oh no.
Don't worry about
That's
it.
my fault. That's my fault.
No, it's because I didn't know exactly what we're doing here. Okay.
So for those on Rumble, on my end, sharing the screen, this is Mark D'Antonio. This is SkyTour live stream. And in the very near future, Mark will also be streaming to Rumble. You're getting an insight of what he does. And he and Daryl do an amazing job during these live streams with his observatory in Arizona. So you're seeing actual images being broadcasted from that location, and he can control it remotely. Mark, I know I don't want to interrupt your stream because I know you're in the middle of discussing. What exactly are we looking at right now?
Oh, I gotta fix that. There's a cluster. I'm trying to get Daryl back in the call here, so keep talking to your people. I'll be right back here.
Okay, so he's been doing this for quite some time. He is a brilliant astronomer. This is an educational experience. This is science. This is astronomy. And he also has a great sense of humor. He provides so much information that sometimes you have to go back 2 times to watch it over, or even more. It depends on, because you have to absorb all the information that he's providing during his streams. I encourage those that are into science and astronomy to follow him. I will give out the information in the next few days during my streams where to find his platform on Rumble, because that is the plan. It will probably be SkyTour live stream with Mark D'Antonio on Rumble. That's not set in stone, but Mark will work on that in the next few days. But he, like I said, he does a tremendous job. He speaks at a lot of events. Actually, he's going to be packing up. Are you going to literally pack up the telescope, or you got another one to take with you to Contact in the Desert and Roswell?
No, I'm actually. I think Daryl's with us now.
Yes, he is. What's up, Daryl?
Hello, Bill.
That
No,
was my fault.
No, sorry, I messed up. But anyway,
Share the screen again.
yeah, I can do all that. I'm working on it. So for Contact in the Desert, we're actually going to be doing a live observatory feed from the observatory in Arizona.
Okay.
So people are going to get to see everything that we do, but I'll be live on the stage, and I'll have a chat like you see here, and Daryl will be with me as well, of course, via the call as normal. And then we're going to do what we're doing tonight, but live, with a live studio audience. It'll be kind of fun. So,
Now, Contact in the Desert is one of the biggest events that happens every year.
yeah.
It's really a UFO focused event, but it's also based on scientists
Yeah.
from all Yeah, you know how it is, Mark. They bring everybody in.
Well, I've never spoken there until this time that they had me. They asked me to come in, and one of the things is they're doing a science-based conference this time, and it's not been a science-based conference in past times, you know. So this is going to be kind of new, and so I'll be very interested to try it and see what we get.
So, gentlemen, what are we focused on tonight over here on this stream? What do you guys?
Well, we're looking at clusters tonight. This is a cluster of stars, and this is a star that has actually died, and it looks like it's in this cluster, but in fact, it's an illusion. Because if you look at my image down here, okay, the nebula is way up here, and the cluster is several thousand light years further past it. So this is a foreground object, this little cluster right here. In fact, I think pretty much people know, but I'll just show you. That's the thing that's a foreground object. Okay, that's our nearby planetary nebula, named because planetary nebulae in a small telescope, they tend to look like little round, faint potential planets. That's how they were named, and the name stuck. It probably shouldn't be planetary nebula, but they never changed it. I think they should call it a stellar remnant nebula.
So, what part of the sky, like in general, if we were thinking constellations, is this located in?
This is
Canis Major.
Yeah, this is in Canis Major, and it's just a little bit to the west side of the southern meridian, where south is, a little bit to the right. If you see Sirius in the sky, okay, the brightest star in the northern sky, or in the sky, that star, you look a little bit to its left, and that's where this is located. All right. In fact, if we bring up our planetarium view, all right, and we bring up our planetarium view, you can see this is Sirius right here. And of course, this is the dog constellation. It's the constellation of one of Orion's hunting dogs. Okay, and this is the star Sirius, which is the brightest one in our sky, like I said. Okay, and we're looking at something right here. So,
gotcha.
Yep. So it's actually not too far away. You'll be interested to know that if you look at here, you can see that Orion here. This is Orion the Hunter, right there. Okay, Orion the Hunter is already setting almost, and it's going to be hard to see anything in Orion. That was one of our, most fun, enjoyable constellations to hang with in the winter. Okay, and it's rapidly going away, but it leads to new things, because now, coming up on the other side of the sky, are the galaxies of spring, and they're going to be here's the moon, right? Okay. This is Leo, the lion, right here. You can see the lion, okay? And this planetarium system is tied to our telescope, so we can move the telescope with this planetarium system.
That's excellent.
It is. And so people get a really nice view of the night sky. We can zoom in a lot on many things, okay? And just, pull ourselves in. Okay, that's Virgo, the Virgin. Kind of looks like a beach model there, but you can see her there.
I always imagined her as a sort of a Mae West type.
Oh, okay.
If Mae West was a virgin, that is.
I guess. Yeah, and you'll notice these little, if we zoom in on this, okay, you'll see now that we have these little ellipses, these red ellipses, these are galaxies, okay? And there's plenty of galaxies. The more we zoom in, the more we see, okay? And it just becomes now even more plentiful as the more we zoom in. That's why it's called galaxy season. Look at all these galaxies, and in fact, it's interesting because this galaxy right here, the Virgo galaxy, this is the one that we saw the black hole in a couple of years ago. It was that black hole was found in this Virgo galaxy, So that's actually quite an amazing discovery.
So I'm going to ask one more question. I don't want to interrupt your stream. I
We're
just wanted to
fine.
share this on Rumble so they can get an idea
Yeah.
of what's coming to Rumble. But when we see these images, and both of you can address this, is this in real time or are these snapshots, images?
Well, we took this image. We took this image in real time. Okay. Now I'm done with this one. So what we're gonna do is I'm gonna save it. Okay. So you'll see the save line go across the top. Now what does that mean? It means that by saving this, this now goes up to our server, and our server can be found by going here to skytourlive.org. And you scroll down to the next gray panel and say, take me to cool images. And you'll see this exact image that you can now take and download, put on your backdrop and anywhere you want. It's really cool. And now if you want to see it in real time, well, that's something else that we do, because what we can do is go to our, what I call our night vision mode. Okay. And that's this mode right here. Okay. And this is it. You see how you see it shifting? You see the noise shifting back there. This is a live view of this object, and it's a zoomed version of our sensor. Right? We're actually zoomed in a little bit. So if we actually zoom out to the full extent to give it a better to give you a better idea of what you're looking at. Okay, this is the full size of our field, and this is 4 full moons across by 3 full moons tall. Right? So that's over 2 degrees wide and 1.5 degrees tall. So that's a pretty big field of view.
Now, is this view also dependent on the ISO gain on the camera? To give
Yes, that's right. And so that's a very good point. So let's talk about that for 1 second. Okay, this right here, this is our exposure. This is a very important parameter, right? The exposure that's on there. Well, there goes a satellite right there. Okay. And the next one that's important is this one. This one here is what you just said, the gain. See that? Okay. And the gain, these two parameters are among the most important things that we use. So the exposure, how long we're going to expose this light onto the sensor, and then the gain, which is how sensitive we allow the sensor to be. And both of those together, we have to balance and do the right amount, okay, so that we can actually get a proper exposure. So if we were to, set this to a very, very high gain, okay, like right now it's at 250. Well, let's take it up to one of the highest we can go.
Wow.
Let me show you what that looks like. Okay, now that you say, that looks crappy. However, if we normalize that, you'll see that we have, it looks very fuzzy, right?
Wow,
and that's, well, it's looking fuzzy, okay, but it's in real time, right? Now, we can actually reduce our exposure a little bit and make it, let me actually do it. That's 8.
There's pros and cons to it because it increases the light aspect of seeing more visually with the stars, but it just looks more pixelated because it's at a higher setting.
That's right. The higher gain makes a lot of noise, so we balance that. We have to balance that, and where we live typically is at 250 gain or so, right? And I'll just move that down.
Usually at 300, aren't you?
Yeah, but on a moonlit night.
Yeah, exactly. I was going to say.
Yep. So, and then, so there we got to take us down to 300.
That's beautiful too, though. That
It's really pretty.
What you can do is incredible on here.
Well, you know what? We spent a couple years just in the planning stages getting this all planned out, and thanks to Marianne Robb, who's in the chat, and Tara Diulis. Yeah. Because of that, obviously, this exists. Without Marianne and Tara, none of this would exist. They're basically the people that take care of all the details for me out in the desert. In fact, Tara and Marianne had to do a service call in the telescope, which you can see in the building right here, Okay, they had to go out there, take that off the pier that you see here, and take it 2 hours south to Tucson to get serviced and looked at, and then brought it back and reinstalled it on the pier themselves.
Wow.
Then they did it right, 100% right.
Wow.
Mark,
Yeah.
you should show Bill how it works. Go look at a cool object and show Bill what's involved in capturing the image. Thor's
Okay.
helmet, maybe?
Well, maybe. I think that Thor's helmet.
Like I said, I'm sharing this on my stream so people get an insight of what you both do.
That's cool. No, I like
during
it.
this. But one more question. I'm going to address this one to Daryl.
All right.
Yes, sir.
Daryl, what is the importance of having a telescope like this located in a site like in Arizona? Why is that so critical as compared to, say, where I am with more of the light pollution?
Well, you just answered your own question. It's dark desert skies out there, low humidity, very clear, and quite dark skies, and that's better conditions for observing and especially for imaging.
That's right.
Because where I'm at, there is no, I mean, I'm not using a telescope, even though I have one. But the images that you will see here on SkyTour live stream are stunning. I mean, what they do here, the both of them, and sometimes they have other people that join them in the show as well.
Yep.
It is truly amazing to have this experience, and it's an education, and they make it fun. It's enjoyable. The sense of humor is put in there. One thing about Mark D'Antonio that I know personally by seeing him do presentations, he is one of the best presenters on anything he does. He keeps people engaged in person, and he'll keep you engaged with Daryl while they do these streams on SkyTour live stream. So for those watching on my Rumble channel, Mark will be joining Rumble in the, like I said, in the near future. And when that happens, I will let everyone know, as well as Mark. So look forward to seeing SkyTour live stream.
Here you go.
With Antonio
Bill?
and Mason. Yes.
Hang on. Mark's about to lay it on you.
God, look at that.
This is live. This is actually live. You saw a satellite come through.
Beautiful.
Okay, and this, just to give you an idea, I'm going to show you. Now, we have a waxing gibbous moon. So, in other words, 3/4 full, right? Moon. All right? And it's really bright up there. And we want to be able to, image faint nebula. So, how do we do that? Well, within our, what we call the optical train, that is where the light goes in and comes out to the camera, there's filters in there, and the filters eliminate as much moonlight as we can. They take out as much of the extraneous light from any light pollution, which we don't really have. But the closer we are to the horizon, the more the light can be influenced by anything like that. So right now, these numbers mean we're guiding on the Orion Nebula. So why don't we just so you can see, as Daryl mentioned, let's see if we can take a shot that would be worthy. I'm pretty sure it will be. Okay, let's... here we go. I'm going to do a maybe 25-second shot. Okay.
Are they overlaid the images, or it's just the one image that you're taking the shot of?
This is just an instantaneous image.
Okay.
Okay. But now I'm going to do something a little different. All right. So we're now going to take a 25-second image. So this is night vision mode. So we got, that's why it looks green. All right. But now what we're going to do is we're going to do what's called a stack.
Yep.
Okay.
Yep.
I will clear the last one. All right. And now a stack is we take one image and then take a second image, align it with the first, and put it on top. And just keep making an image sandwich. the faint stuff rises to the top in terms of being visible. The first one you see, we won't really see it, okay, because it looks a little noisy right now. But now, if I do this, if I will, I mean, look at that. Yeah, and this, the moon is out too, so this is really crazy. And let's adjust colors. Okay, you notice the dust? Now you don't really see it too well, right? Because it's actually, pretty bright out. Plus the Orion Nebula is near the horizon.
God,
But
look how beautiful that is.
oh, it's beautiful. It is. It's gorgeous. And this is again, look at that. That's the Orion Nebula, and it's powered by the stars that are in here that you can't see right now because it's blown out. It's so bright. But watch this next one. After you see this next one, you're going to start to see that this stuff, you'll actually see it coming out brighter and more clear. And that's what we're seeing now. We're seeing now that around the Orion Nebula, we actually have gas and dust out here. And you'll say, well, wait, where is it? I don't see it yet. Well, we can adjust it on the fly and start showing you that. Okay?
That's amazing.
And if we adjust the colors, okay, and make sure we keep adjusting the colors, and then do this, start to add some contrast. Now you can start to see the dust out here. And this is near the horizon, and that's near the horizon, it's difficult to show all the detail. But now the more we do, the more we see. See, and there's a limit to what you can do with that. You can't do too much of that. But you can see now we have all this dust out here, all throughout here. There's all this dust around the Orion Nebula. And at any time, what we could do is we can actually take down that overall brightness just enough so we can actually see what it might look like if you could pull down some of the detail, and then we can just bring it back slowly and watch.
Is still stunning.
Yeah.
I think, Mark, you can correct me, but I think Tara has taken some of these images and framed them and put them on the wall in her home.
Actually, Marianne did that.
Oh, it's Marianne.
And then Tara actually has a whole set of her own as well now. Yeah.
And these images are available at skytour.org, is that correct?
Yeah, SkyTourLive.org.
There it is,
People
SkyTourLive.
can just go right up to the website and download them from our server. Our server has over a year worth of photos up there that we've taken. These, as nice as they look, they basically aren't nearly as good as the processed finished ones that we do. And those processed ones are stunning. And when we
but you know how I always cut you off. I apologize.
I know you always do, and I chase you out of the room, but that's fine.
But if the moon wasn't out right now, I'm sure you would get a lot, like you were saying earlier, because it's washing it a little bit. I'm sure these images could even be better, correct?
Oh, absolutely. And if you notice, look where the telescope's pointing. It's pointing that way. It's like almost looking toward the horizon. So we're seeing an Orion Nebula through a lot of air in the Earth's atmosphere. So it really could be a lot better. All right. So if we come back to our star, let me just move this up a little. We come back to our planetarium system. Okay, you can see that we're here. All right. If we go up to Alnatak, it's actually a little higher. All right. And I won't save this because it's so close to the horizon. So I'll clear it. All right. And get rid of it. Get rid of the stack.
So will the telescope, like you mentioned earlier, the telescope will automatically adjust to go to that location? Because it's tied into the stellarium, which I think is what you're using, right?
Yeah, watch. So what I'll do now is, there it is, right? There's the Orion Nebula. And then in our planetarium program, I want to go here. So all I have to do is tell the telescope, go there. And now you watch here, and you'll see how the Orion Nebula is going to zip away.
It's doing it now.
And it's moving, and you see the telescope moves a little bit.
That's wicked. That is so freaking cool.
And there, here we have.
It's called a go-to system.
That's right.
Yeah, I have that on my telescope.
Yes, you do.
Carol.
You do, Darren. You do, Bill. So this star, and I'll show you here in a sec. Okay. Let's move this up. We'll move a little west. Okay, because I want to show you something really important here. Okay, this star right here is the leftmost star in Orion's belt. The other one is just out of view up here to the right, and the third one's a little farther up. But what I want you to see is what's here. So watch this. This is what we're looking at now. And so now what we'll do is we'll take a 30-second shot of this right here.
And folks watching, this is what you don't see, obviously, with the naked eye.
That's right.
But what with the equipment and the technology at Mark and Daryl's display, right now what they're doing is incredible. It's incredible.
Yeah. So what you'll see now, again, and this is with a waxing gibbous moon where literally it's 3/4 full. And the whole sky is bright right now. Now, one of the things that we also have is an all-sky camera, which I'll bring up briefly and show you in just a second. But here comes the first image, all right? Look at that. This is the Horsehead Nebula, a dark nebula. And first things first, let's adjust and get it properly set up. Look at that. Isn't that stunning? Okay. And this is with the moon, and this is near the horizon. So it's actually not remotely as good as it can typically be. But I tell you, it's really, really gorgeous. Anyway. So look at that. Isn't that amazing? It's pretty.
When you look up the sky and see Orion's belt, it's like,
yeah,
there's a lot more to it than just that.
That's right. This is the leftmost star in Orion's belt,
Unbelievable.
Right here. So it's developing right before your eyes. And now let me do this. I will show you. Go ahead.
Both of you, that is gas. That's gaseous clouds that we see there, right? Is that correct?
That is correct.
Yes, it's ionized hydrogen.
Yep.
Puts out a characteristic red color.
Yep.
Wow.
Bill, you asked about dark desert skies and light pollution earlier. If you were out in such a dark sky and you looked at Orion, you would get hints of the stuff we see going on here. You could actually see the Orion Nebula naked eye from a dark sky.
That's right.
And yet for all that, what we see by eye pales compared to what you see with the images.
Yeah. Now here is an example of what we're actually fighting with the moon. This is...
Bright it is.
This is our all-sky image. Look at that.
That is super bright.
This is 180 degrees, lens. So you see horizon to horizon in every direction and 360 degrees around. Okay. So look how bright the moon is. And still, okay, if you wonder where Orion is, well, you can see Orion in this view, so you know where we are. I'll show you. Okay. Here is Orion, right here. Okay. There is the belt in Orion, right there. And we are looking right here at the leftmost star.
Wow.
Okay. That's where we're looking.
That is amazing.
Yeah. And I think that's really important. So that said, we are looking at that tiny little spot right there, and the moon is really, really bright.
And yet you're still able to capture those kind of visuals, images.
Yeah. Oh yeah.
With them like that.
Yeah, that's right.
That's why I say it's amazing. If the moon wasn't out, oh my gosh, I can imagine. And like you said, some of these images a lot of images actually are available at SkyTourLive.org, correct?
There's over a year of images like this are available, and these are ones taken with the moon out. Without the moon out, oh my gosh, some of the images are stunning. In fact, what it could do actually is to show you, and I think that I could do that. So why don't I show you what we're looking at just quickly? So I'm going to take you to STLS.SkyTourLive.org, and then you can see.
So those that are watching on my stream, this is SkyTour live stream with Mark Antonio and Daryl Mason live.
So
right
here,
now this is being done on YouTube, but trust me, shortly those here on Rumble, you're going to see this very soon.
Oh yeah. Yeah. And let's see if I can bring this into here more. Okay, so there you go. So now you see it right here. Oh, sorry, the camera's reversed. So if we scroll down now, so here's what we got. Okay, we have our Patreon page. I'm actually gonna try and increase the size just enough so we can see some other stuff here. Okay, so our Patreon page is right here. This gives you the different levels. SkyTour Livestream is this stream. That is an example of the very thing we're looking at, but without a moonlit sky. Look at how beautiful that is. That's the Horsehead Nebula.
That's stunning, that
Yeah.
image, yeah.
And then if you want cool pictures, well, let's go to the online database. We'll show you. Okay, so this is our online database. And this is April 2nd, 2023. Hey, that's today. Sorry, that's yesterday, but it's after midnight, so it's April 3rd here in Connecticut. But, okay, remember, we did the little beehive. We did this one with the we just talked about with the planetary nebula in the center, and here's that image. Free for the taking. There it is. And it's going to get clear here in a second. But this gives you an idea of what we did. Now, this was shipped out of the observatory and sent up to our server. Okay.
Incredible. In
Yeah.
real time, too. It's just
Yeah, yeah.
instant.
Yep.
And it's lovely.
Yeah, and that's again with a nearly full moon out. All right. So that is, that's what we did. And then we had, so this is the four objects I captured tonight so far. All right. So that said, this is cool. Now you can also go down. You want to get photographic prints? You can get photographic prints as well. You can get them on metal. You can get them on canvas. You can get framed under glass.
Wow.
And they're very high end. And then this is an example of our this is the Horsehead Nebula. This is the area that we're looking at now. But if you want to see what the moon does to it, well, this is what the moon does to that image. It kind of makes it a little more difficult to see. Okay? But nevertheless, we still get a reasonably beautiful view. All right? There's another beautiful view. That's something that we photograph often. It's called the Christmas Tree Nebula. I think this is called Dreyer's Nebula. This is a composite, actually a mosaic that we made. And the Cone Nebula right here. There's a lot of interesting stuff in here. And these are all like 20-second shots, of globular cluster. This is a double cluster in Perseus. It looks beautiful. It's like a twin jewel box in the sky. This is the Orion Nebula.
Gosh.
You see, without the moon, look what we get.
Wow.
You don't even recognize it anymore. Yeah, and that's a 35-second shot.
Beautiful.
Yeah.
So all of this is available at SkyTourLive.org.
Live.org, right there, yeah. SkyTourLive.org. This is Casper the Friendly Ghost Nebula. This is the elephant's trunk, this beautiful gaseous protrusion, and this is called the Caravan. This weird dark nebula there. And that dark nebula is where it's at. That's where life comes from in the universe. That's a hot button for me. And speaking of the universe, this is a galaxy called Messier 33. It's over 2.5 million light years from us.
Wow.
And it has its own Orion nebulae in it. As you can see, the little red objects in here, these are nebulae of all kinds. Some are large, some are small. Okay? So it's actually overloaded. And then next to it, of course, in the same sky is the Andromeda Galaxy. And these blue stars, these are hot blue young stars called OB associations, O stars and B stars. And this galaxy has a satellite galaxies around it. This one here, Messier 32. This one here, Messier 110. This one here is Messier 31, the Andromeda Galaxy. Messier is the name of the catalog created by Charles Messier. So as you can see, there's the Heart Nebula. Again, a stellar nursery. The Rosette. This is stunning. This is actually something we could look at right now. But again, the moon was gonna make it look kind of washed out on us like this.
Now
But-
remember, these are all images that you're seeing right now that is taken from the observatory in Arizona.
And that's the observatory.
And there it is. That is incredible.
And you see the STLS door. That's actually the Orion Nebula, created
Tara.
by Terra Diulis. Yep.
Yep.
Yeah. And what's interesting about that? Okay. What's interesting about that is that the door itself, right? And I want to see if I can, if I have it here somewhere. I might actually be able to show you.
Are you going to say like what it consists of?
Yeah, and I'm trying to
I
find
wanna
it.
blow- Yeah, I'll wait till you put it up and you, because it is amazing what it took to create that.
It is.
Tara.
And let me, Daryl knows what it is too. But let me see if I can find
And
a
how
photo.
artistic and talented.
Oh yeah, she's something else.
And
Something
thirsty.
else. Yeah, there you go.
Yeah, that's funny, Daryl.
No, I'm not
Oh my
leaving.
God.
I'm not leaving you. I'm just trying to find. There it is. This is what we want.
Believe me, it took dedication.
There it
Absolutely.
is. Okay. Now, so you see, that is a mural made entirely of bottle caps.
Yep.
Okay, and she put all this time in, and that's why Daryl said "and thirsty," because the orange ones that make up STLS, I can actually show you that. Actually, let's see if I can move that. Well, underneath SkyTourLive.org that I have there is a STLS in yellow, and that's made of a particular type of drink. None of these bottle caps were painted. The darker blues are Bud Light. The reds
that.
are another one, and the whites are a different one. And she actually collected bottle caps over the years when she actually worked at a restaurant, you know. So it's pretty cool. This is our live chat going on right now. You can see.
Yes, nobody, I don't think ever guessed how many bottle caps, Kathy.
Nope, nobody guessed. I wish they had, but that's okay. So anyway,
What did I always say? 1,326?
yeah, you always had that same number, and it was always wrong. I love it. It was funny. Yeah, it became a running joke with us. Okay.
Yeah, that's incredible. Well, gentlemen, I'm going to let you both continue your stream. Thank you for allowing me to come on with both of you and share this experience with everybody that's watching my stream. And I will keep everybody informed when this is going to be streaming on another platform. Because right now he's streaming on his YouTube channel, Sky2 Live Stream. He's also streaming on Trovo and Twitch as well and Facebook. But this is coming to Rumble very soon.
Yes.
I will keep everybody abreast of the situation when he is available. And trust me, it'll be done probably by the end of this week at the latest.
Well, I have to film for A&E on Thursday, so I don't know if I'll get to it this week.
All right, well, I will let them all know when it is available. So
Yeah.
thank you both for what you do, and hello to all those that are watching on his stream. Support what they do, because this is something that we all need, and this is not something you would see in mainstream channels. This is incredible. The insight, the educational experience that you will experience here,
Yeah.
watching streams. Just simply.
Thanks for coming, Bill.
Yeah,
All right,
thank you.
gentlemen. Have a great rest of your morning or night where Daryl is, because it's still not quite Monday yet. And thank you
Not
for.
even 10:30 here yet.
Yeah, it's early still for you, but thank you for what you both do.
Hey, thanks, Bill, for coming on out.
Take
All
care,
right,
Bill.
Have
Don't
a
be
great night.
stranger. Come back.
I will. Have a great night, guys.
All right, thanks,
All right.
man.
Bye bye.
Bye. All right, so I gotta get this arranged again. I don't know how this got out of whack here, but it's all right. I'll fix it.
I see several open windows. Open
Oh, don't worry about that. I don't,
Skype tabs.
Okay. I don't know where that's coming from. Well, actually, I do. That's from Bill. All right. So let's just get this. Let me get this back to where it belongs here. Flick. All right. All right. Hang on. I don't know why that actually did what it did. I'll lock this. And that looks like it's correct, finally. All right. So there you go. So there's the Horsehead Nebula and the Flame Nebula. They, again, could look much better based on using the proper exposure with the moon out, and well, this is the best exposure you could get with the moon out right now. And they're very low. Look where the telescope is leaning right now. It's literally way down low. That's okay.
Yeah. Orion's going to be start setting in half an hour.
I know it. It's almost gone now. It's almost gone now. All right, let me just do one more little thing here. One more little thing. I'm just going to make an adjustment.
We should have Bill on more often.
I know. I try to get him on a lot, and he doesn't have the time because of what he does with KGRA.
Yeah, I know it. We should get him to break his telescope out and learn how to use it.
Yeah, operative word learn. He needs to learn how to use it.
Yeah.
I agree with that.
Michael, Michael wants to look in Virgo at that comet.
I think
I don't know if Virgo's up high enough yet. But
yeah, we'll check it out. Let me finish arrangement here. I don't know why this is doing this. There we go. All right, and then this comes over. Okay. All right. Okay, good. So, all right, so there you see the Horsehead. Again, it's very low, so we won't save it. But those are 33 stacked images of it. And now we'll go back to our real-time view. Okay, let's do that. And go to our night vision mode. Okay. Not sure we'll see the comet very well with the... Look how close to the horizon we are. Look at that. It's like literally right down below here. So, I'll need the coordinates of the comet. But let's first of all go make sure that we can see at least something in Virgo. Keep in mind that the moon is it's in Leo, Virgo area, so it's going to be kind of tough to see it. There's the moon. And if you look at Regulus, Alpha Leo, it's right there. That, of course, is the Lion, and here's Virgo down here. Do you have the coordinates?
He posted them.
Okay.
15 hours, 9 minutes, 31 seconds.
All right, well, just a sec. I'm going to put those in. So 15 hours.
9 minutes, 09.
Okay.
31 seconds.
Okay.
Declination.
Okay.
0 degrees, 39 minutes, 5 seconds.
Okay, I'm going to just put in. I'm going to put in the colons here. Okay, so 15, 9, 31, 0, 39, 05. Okay, we're going to try it, guys. And now what you're going to do is you're going to watch the telescope. It's going to swing all the way up to the other side of the sky. There it goes. And it might get a brighter sky here with the moon. But we're going to see, this is the eastern side. All right, and the eastern side of the telescope observatory is there. See how bright the moon is? Let's see if we can see it. Yeah, see, we're hitting the it's too low.
It's not that low.
Yeah, I guess we might have gone to the wrong coordinates.
Goodness, that's almost on the horizon.
Yeah. Well, let's see if we can go back. Let's see where it thinks it is.
Michael, where did you get the coordinates?
Here. We're going to go up toward the moon here. And it'll be too bright, but we'll look at it anyway.
Different comet. It's a different comet, cosmic ray.
All right. All right, let's drop our gain down to 0. And there's the moon. And we're going to just go west a little bit. And go up a little bit. I promised you we'd check out the moon too, so that's why we're doing it. Why not? Okay. All right. Okay, so what I'll do now is I will bring this down to like 5 milliseconds. And now you see the moon. And that gives you a good example of how big our field is. Because 4 full moons fit across the field and 3 across from here to here. So that is what we got going on. All right. Okay. And I can see you might want to refocus here. There we go. Interesting, because we focus on stars. The focus on the moon is a little bit different, which is kind of interesting. There's the crater Plato right there.
I see Aristarchus.
Yeah, we have Aristarchus right there, and the Aristarchus Plateau. Right near Herschel, I believe. And then we got Copernicus here.
Brightest spot on the moon.
Yeah, that's Aristarchus Plateau, yeah. And there's the crater Tycho. Down below is Clavius, which you can't really see yet. Well, anyway, that's pretty cool. And let's now let's try something. Okay, if we go bright now and back out a little bit, let's increase our gain to about 100. increase our photo. You can see the other side of the moon. It's not lit yet. It'll make it a full moon. And if there was slightly less of the moon illuminated, we would see stars around the moon here, because we're actually doing this longer exposure.
Mark, I pulled it up in the Sky Live where Michael is getting his information on that comet.
Yeah.
It is down past the feet of Virgo, almost in Libra.
Okay, so it is that low.
It is that low. You probably can't catch it yet.
Yeah, I cannot, because I was pointing down to exactly into the wall.
Actually, it's not in Libra. It's almost in Serpents.
Okay.
Serpents kaput.
Wow. Asher, how you doing?
Southeasternmost Virgo.
Yeah. Asher
If I
says...
said Leo, I meant Virgo.
Okay. Asher asked a question. He said, can you please save a photo of this, Mark? What was it, Asher? I mean, how long ago was that? I missed that. I'm sorry. Michael Hedrick, I did not see that news. He says, Mark and Daryl, did you hear NASA and Canada are announcing tomorrow who's going to travel around the moon on Artemis? I did not. Dean Bossador talks about his dad, who used to bounce waves off the moon as a ham operator. Yeah, I heard all about that. That was always cool. Excuse me. All right, let's go now. Let's go here.
Mark, I sent you a link to
the comet.
If you want to show where the comet is right now.
Oh. Okay. I think that was in the other call, right? I think maybe that's where you did it. I don't think so.
Well, there's too many calls.
I know. All right.
Give me just a second.
All right, thank you.
Well, no, it's in the chat for your current live shared window.
Huh. Okay. I might have covered it over or something.
I mean, your screen that you're showing me right now.
Yeah.
That's where I put the chat. That's where I pasted it into your chat.
Yeah. Okay. I still don't see it. And this is what I see. Maybe it's in here. Okay, there we go. I got it, folks. I got it. We got it. Okay. Yeah. Well, we're going to wait on that anyway, Daryl, because it's just too far down. And I was going to look at the Leo triplet, but that's actually so close to the moon that we might not even see it.
Right.
So let's go back a bit. Let's go back a bit. Oh, wait a minute. I know what we can do. Let's head up north. Let's head up north. All right. That's good. All right, guys, I got something to look at that I think will be fun. So you watch the telescope's going to swing way back. Yeah, let's... Here we are. And again, we are on... I got the gain down again. Let's bring the gain up to our working gain. 250. And we got these two objects. These are two amazing galaxies that we really like. The top one is Messier 82. It's known as a starburst galaxy. And a starburst galaxy is sort of just that. It's a galaxy where stars are being produced in a really prodigious and out of control rate. And it's pretty clear when you look at it. It's pretty clear when you look at it because you see this amazing redness in this upper galaxy. All right. And again, we have to bring it up higher. Now, we're facing far away from the moon right now. But let's zoom in so you can see this. Look at that. Again, this is live. There you go. That's live. Every second, the image changes. So you see that red thing? That is actually just part of it. There's a huge wave of red gas coming out of this galaxy, produced by the stellar population that's being basically created in there. So if we're going to back out, this one is a beautiful spiral galaxy. So why don't we set this to a 25-second shot, which is almost too much for these two. They're pretty bright. So let's do that. 25 seconds. All right. Okay. Okay. Here we go. And off we go. Let's bring in the stack. And now you get to see these. Okay. Right now, those are a little bit bright. High contrast. I'll fix that. Okay. Okay, here we go. Okay. So I'm color correcting and take it like this. Color corrected and give it a little processing. And you can see in this galaxy up here, you can see how it has these tendrils going out north and south. And those tendrils, north and south, we can, we've only got 4 images stacked here. As we get more, we'll see more detail in this. So let's try to get more detail. Okay, here we go. Look at that. All right, we'll see that in a minute. That's pretty. Look at that. That's really pretty.
It's red.
It's not supposed to be. But that's a problem with the moonlight. It messes with the photo processing. See, this is where it thinks it wants to be. And, right here. And that means we have to pull out some of the red manually. And if we pull out enough so the galaxy looks right, then the sky looks a little bit too blue. Because we're fighting the blue color in the sky from the moon. But what you can see, though, is the differentiation between the spiral arms with the young hot stars in them and the nucleus with the other older population stars in the middle. This is where the young stars are born in the spiral arms. So that's why this looks kind of blue. Pretty cool. Neato.
Excuse me just a moment, please.
Sure. Okay. Now let's go back and look at Measure 82. Now you can see how these areas here, you can see they're splashing above and below. Isn't that cool? Let's zoom in. We have 11 stacked here. And let me take off our enhancement. Okay. Now you can see even clearer. You can see this beautiful reddish core that's moving out down below and moving out above. That's incredible. The color rendering is off a little because of this, but you can see now it's above and below. Really neat. Cool. So that's M81 and M82. Oh, no it's not. It's M82 and M82. Gee, could somebody have done a better job on that? I think so. That's better. Alright, so we'll zoom out to show you those both. Here they are. There we go. You can see the knots in the spiral arms down here. That's really cool. If any of you are watching in Facebook, let's hear from you. Very nice. Hey there, Bullwinkle. How are you? That's pretty cool. Let's put the sky the proper color. Now the galaxies aren't this red. This is just the way they look when the moon is out, especially when the moon is large in angular size and coverage. But that's okay. We'll do one more because I'll keep this even though it's not quite correct in color, because we can fix that.
Mark Prow is here.
Hey, Prow.
He was wondering if we could look at M104, the Sombrero, which is also in Virgo, but it's in Western Virgo.
All right, well, we can see if it's up for us. Hello there, Jose Santos. How are you? Okay, we're gonna save this now. There we go. And we'll save it exactly as seen. All right. Okay. Now, let's clear this and move on. So we're gonna do the, we're gonna try to see the sombrero, huh?
Yep.
When we're ready, we can try that.
Should be due west of Spica. You might be able to catch that.
I might be able to.
Pretty much due west of Spica.
Mm-hmm. Okay, so there's our night vision mode. Okay, let's go to our planetarium.
Mark, Streamlabs timed out
Oh,
Jose Santos.
okay. I don't know what symbols he used. Jose, sorry about that. That's this is our first time using Streamlabs. Tonight was the very first time we've done this. And multi-streaming, streaming to multiple platforms at once. So I apologize for that. On the next stream, I will fix those things. All right. So I apologize.
People are asking what Streamlab is.
Streamlabs is our new broadcast software. It allows us to broadcast to not just Facebook, not just YouTube, but to Facebook, Trovo, Twitch, and soon Rumble. I mean, I'll be able to do that. So we're going to a total of 6 locations. And that's very important, you know, to spread our wings, so to speak. So that said, that's not bad. And I appreciate all of you guys that are here. And we'll just continue to do everything we're doing. All right, let's look for M104. Okay, M104. Now it's going to be all the way on the other side. There it is. Let's see its elevation. Well, we could try it. It's going to be 33 degrees or so. Why don't we give it a shot? So I watch the telescope. It's going to go swinging around the other side of the sky. Right there. There it goes. Alright, we'll come in here. Let's get rid of that. Yeah, it looks like it's going to be just barely able. There it is right there. Now you'll notice these are small. That's because, again, 2 degrees across by 1.5 degrees tall. That's what we've got. All right, we are a wide field telescope system. So for things like the Andromeda Galaxy, we can show quite a lot of the Andromeda Galaxy, which we can't see right now.
Yeah, it looks like you may still be clipping the roof.
Just a little bit, yeah. We'll know once we will know. See, we're moving a little bit north, so that might just barely. We might be clipping the roof. Let's find out. Let's do a exposure of this. We're going to be searching for our guide star here. Once this starts showing numbers, it'll start with all zeros. There it goes. It's all calibrated. Now we're starting to guide. That's our auto-guiding system, incidentally. So, let's see if we can do a 20-second shot. And off we go. So we'll try and stack that right away. And we'll clear that. If you see a solid red haze, then I'll tell you what that is if we see it in this view. Yeah. Okay.
I know what that is.
I know you do. Okay. So what's happening right now is the telescope is tilted over like this. And that right there is the wall of the observatory right here. Okay. And the reason it's red is interesting. On the end of the camera's inside the end of the telescope that's pulling in the light. The camera's sitting off the front of the telescope. It's a special system. And that camera has a tiny red LED on it. Very, very tiny. You can barely see it. But it's a very sensitive camera. So that tiny red LED is illuminating the wooden edge of this building. And thus you can see it. Now you might say, why would they do that at all? They shouldn't do that. It's actually intentional. This makes sure we know that something's obstructing. Now this is how we illuminate the obstruction that is blocking our view. Okay.
Well, usually that red light would be back at the back of the telescope, where the telescope would never see it.
Right, but the hyperstar system that we're using puts it off the front, and you're right. So I could have covered it. I could have painted it black, but I left it out. I wanted to see that red, so it was intentional.
Right.
So that way I have a way to gauge whether we have anything that's blocking our view, knowing how immensely sensitive this is. However, in spite of that, this is not a bad image. Okay, we'll just try and do a little. Okay.
Oh, piece of black electrical tape the size of a fingernail would take care of that.
Oh, yes, it would.
Quick.
Yeah. Okay, so M104 is kind of small, and we can see how much it takes up in the view. It's not a lot, but we can actually try and catch our.
This will be one for the next telescope.
Oh, for sure. Yep. The next telescope, the way what we're going to do, guys, is this is our wide field telescope. The telescope behind me is a medium field telescope for the east, and we're actually going to do different things with that. We're going to do spectral analysis with that one. But the other one that's going to be out in Arizona here is going to be a telescope with a zoomed view. So in other words, if we're looking at this object right here, okay, let's show you this. So if we actually want to go south, I have to come out of it right now. Let me just get out of this. Okay. And then do this. All right. So now, if we actually take our telescope a little bit south. All right, let's do that. Okay. Right. And then take it west by just enough. So the telescope view for the next telescope is going to be just about the size of this inner ring. Okay, roughly. So that will leave us. The whole view would actually consist of this object, filling that or nearly filling the field. So it'll be pretty nice. Because we're not gonna put the special system on there that we have on this telescope. So there you go. Let's actually do this. Let's zoom out of this.
Well.
What?
I said, oh well.
All right. Well, there you go. So you can see that we're going to lose real estate, but we're going to gain this beautiful view. But it's just after 1 a.m. here, so in Connecticut, and we are 2,500 miles away from that telescope right there, operating it from Connecticut out in the Arizona desert. I'm not in Arizona, so that's probably an interesting factoid to a number of you. So, what I'm going to do is I'm going to say that we are done for tonight, because the moon is, of course, dominating our view and makes it hard to take a good image of anything now. But to be fair, once it turns full, it's going to rapidly go past full, and in just a few days, we'll be able to start up at 10:30, and the moon will rise a little bit later, and then the longer we wait, when we do our start at 10:30, which I'll tell you why in a sec we start then we will actually be able to have a nice night without the moon, and we'll take pictures of these things again, and you'll see the vast difference between them. And the reason that the what was I saying? I'm tired. I had a point that I was making, Daryl.
Huh?
Exactly. Okay. I was making a point, and someone in chat will remind me what it was. I'm sure. Anyway, I will definitely be sharing with you. I'm tired, yes. All right, well, anyway, you know what? Best thing for us to do right now is to close down tonight and let it go. Now, we start and end each stream with the same music, and that's this here that we're hearing. So, you guys we'll be back on the next clear night or just after the moon is full. And please enjoy it. Hopefully this streamed out wonderfully on all the platforms. I've been kind of looking so many directions all night long because I feel like I'm not quite all there with you guys. And I'm sorry for that. And I'm getting over a sickness, which is why I'm coughing a lot. Anyway, you guys have a good night, and we will talk soon. All right? So thank you for all who attended, and I look forward to talking to you again. So good night, everybody.
Good night, everybody.